I would like to start my talk by asking you a question. What comes to your mind when you think of synthetic chemistry? Miraculous drugs that cure illnesses like cancer? Or pollution and chemical disasters like Seveso and Bhopal? Synthetic chemistry is often seen as dangerous and damaging to the environment, and with good reason. Many of the chemicals produced or used in the reactions can be dangerous. Now, let's take a step back and look at what synthetic chemistry actually means. Synthetic chemistry is defined as the process of obtaining chemical products through one or more controlled reactions. The most common type of reactor used is a batch reactor. Essentially, a batch reactor is a very large container. The reactants are pumped in, and once the reaction is completed, the products are pumped out. If the reaction needs cooling, it is done so through the walls of the reactor. The larger the reactor, the smaller the surface area to volume ratio, and therefore it becomes more difficult to cool. This means that exothermic reactions, reactions that release energy, can be very dangerous for the setup. This is because once the reaction is started, there is very little one can do to stop it, and the whole thing could get out of control and explode. By now you might be wondering, why even bother with synthetic chemistry then? Well, synthetic chemistry is incredibly important in our 21st century world. Some amazing chemicals are made, and some of them right here in New Zealand. For example, glycosin in Lowell Hut is the only place in the world that makes 6 reagents used to diagnose patients for Morquio-A syndrome. Synthetic chemistry is also used to find cures for cancer and other diseases. It also creates huge amounts of income. For example, New Zealand exports about $1 billion worth of chemicals a year. Synthetic chemicals are also worth a lot for their weight, which is important for us in New Zealand because we are far away from the rest of the world, so we want to keep shipping costs to a minimum. Some high-end compounds are worth on average $5,000 per gram. That's about the size of this tablet here. Imagine this being worth $5,000. In 2014, the total pharmaceutical revenues worldwide exceeded $1,000 billion, and the global market for agrochemicals was over $200 billion. Synthetic chemistry is a growing market that New Zealand has the potential to become world leaders in, but the dangers are still there. If only there was a way to produce these amazing chemicals safely and efficiently. But wait, there is. Flow reactors. What are flow reactors, you ask? Essentially, flow reactors are small-scale reactors where chemicals are constantly pumped through tubes called microchannels. 2 of these tubes move chemicals into a main tube where the reaction takes place. The products flow out the end. Due to their small scale, many flow reactors are needed to account for one batch reactor. So to get more products, instead of scaling up and making bigger reactors, you scale out and make more reactors. The small scale of the flow reactors also means that the surface area to volume ratio is much greater than that of batch reactors. Flow reactors offer many advantages over traditional batch reactors. They offer vast improvements in yield, energy efficiency, reliability and control, and most importantly, a greatly improved degree of safety. The reactions in flow reactors are continuous. The reactor does not need to be emptied and cleaned after each reaction. Instead, chemicals are constantly pumped through. This eliminates any waste of time, instead constantly producing products, which increases the yield. Scaling up a reaction exponentially increases the amount of energy required. Therefore, due to their small scale, flow reactors are much more energy efficient. Also, due to the greater surface area to volume ratio, less energy is needed to cool the reactor if an exothermic reaction is taking place. Flow reactors are also much more reliable. Due to the small scale of the reactor, chemicals combine and react more reliably. Also, it is easier to monitor and control the reactions in a flow reactor. For example, if you have too much of one reactant, simply reduce its supply until the system reaches its desired state. However, the biggest benefit flow reactors bring to New Zealand is the improved degree of safety. On top of being much more reliable and easy to control, the reaction can simply be turned off by halting the flow of reactants. This is assuming something goes wrong, which, due to their small scale, continuous reactions is very unlikely in flow reactors. This improved degree of safety is very important to New Zealand because a chemical disaster could be incredibly damaging to our environment and financially cripple the nation. Of course, there are some situations where flow reactors don't work yet. For example, multi-step reactions are currently not possible in flow reactors, and the reaction cannot involve solids as they'll block up the tubes. Flow reactors are a new technology, so they're quite expensive at the moment. Yet, these are all problems that can be solved through future research, and the potential social and economic benefits of flow reactors are huge. If this tablet is worth $5,000, then only 2 bathtubs would be worth several billion. Synthetic chemistry is a relatively new market that is rapidly gaining popularity worldwide, and New Zealand has the potential to become world leaders in it. Manufacturing high-end pharmaceuticals right here at home will not only benefit New Zealand's economy, but also save lives and greatly improve everyone's standards of living. Flow reactors are the future of synthetic chemistry, and synthetic chemistry is the future of Aotearoa.